Hello. We are going to dig into object-oriented principles today. We have done object-oriented programming, obviously, all the way up till this point. We haven't really focused on the four main properties of object-oriented principles, which are namely abstraction, inheritance, encapsulation, and polymorphism. Now, these are all really, really important, obviously, for any of these kinds of languages. And because they're so important, I suppose, we're actually only really going to get into the encapsulation and inheritance parts in this video. The polymorphism part, we'll do a little bit of that. And abstraction is actually something we're mostly going to leave for next video, where we go over abstract classes and virtual methods. You know, we kind of do breeze over these concepts a little bit in the sense that, you know, any class that we make is in its sense an abstraction. We're not literally, for instance, making food items in the computer. We're creating these concepts of what it means to be a food item, an abstract idea. Not that I can actually reach into my computer and eat a hamburger, you know. I can make something that represents a hamburger, but I can't actually really make one. And this concept is really important to how we actually try to use computers to represent data, to have, you know, data do things, to make the computer behave in certain ways based on the information we have. We're mostly going to be focusing more on the, I think, encapsulation and inheritance and a little bit of polymorphism in this video. Polymorphism is basically this idea that all objects of similar type should be able to be interfaced with in the same way. So for instance, if I have food items and I have drink items, they might all be part of an overall, maybe they might actually inherit from another class that's just called you know, sustenance or food or something. And the idea here being that if I know how to interact with a generic item, whether it's food or drink or dessert or whatever you feel like, that should be something that works regardless of the type I'm working with. But let's just get going in these exercises, and maybe I'll talk about it as we do things. So first of all, of course, it wouldn't be appropriate to do something abstract without talking about art. So we're going to make an art class. Art is going to represent potentially visual or performance art. We'll have some attributes in there: title, artist, year, make a constructor that initializes them, a method that displays this info. Let's give this all a go. So, okay. Now, kind of following along with the way that we've been doing things now, we're going to more properly, I think, set up these kinds of things by using headers and instead of putting everything in a single class. So if I have a class called art, I should have a header that's art.h. Art.h, put the comment at the top, is going to be an art class with all this stuff in it. So let's put all these things here, and we'll actually code it in art.cpp. So we're going to need some strings. So we'll need that. I'm going to have a class called art. My art class, we'll handle making things private later. For now, I'm just going to make everything public. We have a title. That sounds like a string to me. We have an artist. That's also a string. We have a year. That's an integer. We're going to need a constructor. Constructor is called art. Now, we can consider making an art constructor that has all three parts to it. That's one option. I think what we'll do is, I think we'll do just that. So we'll have art with a string, and an integer. Note that I'm not naming them here because I'm going to actually name these variables when I try to implement this function. For now, I just want to tell the computer, hey, there are constructors, they exist. And I need a method to display this information, so that'll be void display art. Sure. Okay, so this is what it's going to look like. At least these are all the declarations that I need to have. And now I'm going to duplicate this into art.cpp. And here is where I want the actual code. Now, I'm not necessarily going to need, I might need the namespace part, but I don't think I need to include IOStream. But what I do need to include is art.h. The whole point of this was so that I can use that header file and avoid having to declare stuff that I know is going to exist already. Now, I don't need to declare any of these things again, because they've already been declared, but I do need to define these functions. So here are my three functions. I got to say what they do. We're going to be a little bit lazy with the art constructor, and I remember I have to specify these all belong to the art class. Art class. We'll be a little lazy and have our blank constructor do nothing. For the one that actually has the strings and integers, we'll assign the title. Oh, we gotta give these names. So this will be title, artist, and year. We'll assign the title, the artist, and the year. And again, we don't need to do anything else, so we'll just leave it. Then finally, to display the art, we're going to need to do cout the title. Well, I guess we'll say, okay, art piece, title by artist, comma, year. So, art piece, title by artist, year. Maybe we'll put it in parentheses, actually. By artist, parentheses, year. Sure. Okay, so here is art. Here is the definition, here is the declaration of it, and here's the definition of the different functions. So now that I have all this, I want to have a main.cpp. My main is also going to need to include art.h. Main. Let's make an art piece. So art A is art, and let's say, what's a good choice? The Scream. Who did the Scream? I do not know my my artist. Edvard Munch, 1893. Sounds good to me. So, the Scream by this person in, I've already forgotten the year, 1893, sure. And we'll do a.display art. Okay. It's nice to have a very short main function. You really don't want to have too much in it, because if I want to be manipulating what it is to be a piece of art, I don't want to have to tinker with this main function. It should just be what it is. Now, I suppose I could make a make function for this. I think I will leave doing that, but it might be a good exercise if you want to get some practice with make files. I'll leave that maybe as an exercise to do. So I do need to compile art.cpp and main.cpp. So now I have my object files, and then I can create art executable using art.o and main.o. Okay, and if I run it, it is art piece, The Scream by Edvard Munch. Sounds good. All right, we're off to a start, and now let's continue on. Okay. Modify the art class by making all of its attributes private and providing public methods, getters and setters, for attributes. Then add an art type variable to the class, which is set in the constructor to a value that denotes its type, such as visual. Okay, so a few things to do here, but something that's pretty important to note is I don't want to change the main too much. Probably I will need to anyway, because I do need to specify when I declare that this is an art object, what kind of art is it? It's visual. But I will need to make all my changes, I suppose, starting here. Now, this was our first exercise, exercise 1. I'll put everything in here. I'm going to copy all of this. Exercise 2. And paste. Okay. All right. Modify the art class by making all of its attributes private and providing public. Okay, so right now everything is public. And although you can do this, you should not. It is a bad idea to do so. And the main reason for this is that anything that you make public is part of what we call a class's interface. It's things that you want anybody using this class to be allowed to manipulate however they want. you shouldn't let anybody manipulate anything however they want. There should be some rules here. For instance, maybe it's the case that a year should not be 5 digits long. Maybe we're assuming that, for instance, we're not going to have this work in the year 10,000. Probably something much different will be around there. You might, for instance, want to make it so that anybody who tries to modify the year isn't allowed to put some absurd number, or even some year in the future or something like that. It has to be a year in the past, let's say. If you let them access the year attribute publicly, they can do whatever they want. They can set the year to be 1,000,000. That doesn't make any sense, and it may cause other parts of your class to break, so you shouldn't. Instead, anything that you want to limit the permissions for should be declared privately. So, all of these are the attributes, and they're going to be private. Now, this won't affect the implementation of these functions, thankfully, because they are members of the art class. Members of the art class can do anything they want with the private variables that are here. But now I might want to, for instance, want to change some of these things. Maybe I may make some rules for that, for instance. So we're going to want some getters and setters for these things. And getters and setters are also called accessors and mutators, are just functions that easily manipulate or retrieve these points. So we're going to do one for each. So we're going to have a string get title. So get title, get artist, and get year. And get year as an integer. And then void set title with a string. Void set artist, also with a string. And void set year, this time with an integer. Okay, so I need to implement all these functions. Fortunately, they're all extremely short. So over in my CPP file, I need to implement all of these. Now I need to specify all of them are part of the art class. Art. And they're usually about one line. Return title, for instance. Return artist. Return year. Title equals, and here I need to give them variable names, SAY. Title equals T. Artist equals A. And year equals Y. Okay. Yeah, sounds good to me. All right, so let's see. Now, I haven't added my art type variable to this class, so I need to do that. Now, it says that it's going to take something like, that looks like a string here, so I'll need to specify that. So string art type. I'll need another string here for the art type. Since I'm adding this art type, it also should have a getter and setter. So I'll need string get art type, void set art type, and in here, same thing, where I'm going to need to have a, we'll copy this, I suppose, art type, and set art type. And art type. Can save yourself a bit of typing time by copy pasting as much as possible. If you're not as quick of a typer, I definitely recommend anytime you can copy and paste things, save yourself a bit of time. It'll make your code a little bit quicker. Okay, this was not the exercise we're doing right now. It's this, which is add our art type variable. Got it. Set in the constructor to a value that denotes its type. So we need to fix our constructor. So our constructor right now needs to have another string at, which is going to set the art type. Okay, so we've updated everything according to what it says we need to have here. Let's make sure our main function can handle all this. Also, probably our display art. should mention what art type it is. So we'll do art type. And our main function is going to say this is visual art, and we'll display it. Okay. Compile. I am in the wrong folder. Let's try that again. Exercise 6, or 2, sorry. Compile. Okay, what did I mess up? I copied the wrong letter. So let me fix some of the code in here in my art CPP file. So this should say title. So set title should be T or A, Y. That sounds good to me. What else have I messed up? Set art type. Did I spell it wrong? I think I did. Void set art type. Okay. Void set art type takes a string. It should take a string. So the error was that I had forgotten to put the parameter in here, and so it got confused because it's looking for set art type with a string inside, but the header didn't have it. There was no declaration that had the correct thing. Okay, fix that. Try again. There we go. And now I can compile and run my art. Visual art pastes the screen. Everything is good. Okay, let's continue. What do we got next? Derive visual art and performance art classes from the art class, adding an attribute and method specific to each, such as size, duration, applaud. Sure. Okay. So if we're going to derive classes, what this means is that we're going to use the principle of inheritance. What we've done so far, the only principle we've really demonstrated, besides maybe abstraction to some degree, is the principle of encapsulation. It's putting these variables into the private part of the class so that people can't directly modify them. If you want to set the year, for example, you have to use set year. You can't do it another way. And that might be useful if, for instance, you want to do something like if year, if y is less than 10,000, then set the year. Perhaps you might want some restrictions like this, which is totally fine. This means that someone can't just set the year to be something above 10,000 because now the only way they can modify that variable is using your method. So this is encapsulation. It's literally the process of keeping something in a capsule. It's locking it away so that it can only be accessed in a limited capacity. That's what we've done so far, but we want to do inheritance now. Inheritance is the idea that something is something else. So if you think of, I think the basic, most simple example of this is vehicles. So a car is a vehicle. If you can think of things that describe what vehicles are things that probably move. Vehicles are things that stuff can, either people can go in or objects can go in. They typically, I guess a vehicle is something that moves, I think is fairly straightforward. And a car is a kind of vehicle, but there are other kinds of vehicles as well. An airplane is also a vehicle. And cars and airplanes both move, but they also have things that are unique to them. So here what we're going to do is we're going to use our art class to derive two subclasses. So the art class is what we call the parent class or superclass, and the child or subclasses are going to be visual art and performance art. And visual and performance art will have everything that the art class has with some extra things as well. In particular, they're going to have these other attributes and methods. So let's derive these classes. Now, we don't need to change our art stuff here. We probably will change our main to make some of these things. But let's start by doing visual art first, and then we'll do performance art after. Okay. So let's make a new file, and this will be visualart.h. Okay, so here's our instructions. Now, how do I derive a class? And the syntax is pretty simple. So I say class visual art, and it is derived from the publicly available class art. So by saying this, I'm saying anything that art can do, visual art can also do. Now, privately, I will have a, let's say, an int size, and perhaps this will represent the square foot area of the art, as an example. I don't need to declare any other variables because they're already available. The title, the artist, the year, those are already part of the art class, so I don't need to declare them again. But I wouldn't say size for performance art because what is the size of a play? That doesn't really make a lot of sense, right? Publicly, let's see, what's something that you might do with visual art? I suppose look. So we'll say void look, just so we have something. Okay, pretty simple. A fairly important thing I'm missing. I need to include art, otherwise we're not going to know what art is. Okay, so we're including art. And now we need our CPP file. So visualart.cpp. So this one's going to include, oh, and I forgot, it should be quotations, not the square brackets. Or the triangle brackets. And this is going to include visualart.h. Okay, now all these, a bunch of this stuff is declared already, but look is not. So I will need to define the look for visual art. And we'll do something like this size square foot piece of art looks great. No, something like that. Actually, how about we include the title? We'll say title is this many square feet, and it looks great. There we go. So title here, although we didn't define it or declare it for visual art, is already declared for art. So we can access it because visual art is a subclass of art. So I can grab the title from here. There is something I forgot. I should include a constructor so that I can actually build a piece of visual art. So visual art. And now here's a part I know I mess up quite a bit. I think I'm going to need for this string int. And the reason is I'm going to need the art type, which is visual, a little self-explanatory, the title, the artist, the year, and the size, because we need to set that up too. Now we have to implement this as well. This is part of the visual art class. Here are all of our variables. We need to give them some names. So we're going to have, what is it? Art type, title, artist, year, size. Okay, now we can take advantage of something, which is our art class also has a constructor. So we can use it, and it takes 4 of those things. So rather than writing a bunch of stuff out, I can just use the art constructor and give it a t, t, a, y, which are all of the parts from here. And also the size will be x. And that's it. This looks kind of weird, but just to break down what's happening here, we're taking advantage of the existing constructor from our art class, passing it all of the art type, title, artist, and year. And so when we build a visual art object, it puts everything in the same way it would if it was a piece of art, and also gives it a size. Okay, now in my main function, to make sure this works, I'm actually going to not make an art object, but I'm going to include visualart.h. And this is going to be visualart VA equals visualart, and I need to include the size. I don't know how big this is, so I'm just going to put in a number. It's definitely not 20 square feet. Let's say that it's, I I don't know, 4? I have no clue. That's okay. And we'll do va.look. Now, this probably won't work, but I think I know why. So let's see what happens if I try to build this. So to compile this, I need to compile. Oh, did I, I made a blunder here. I forgot to copy everything to exercise 3. Oh, okay. That's okay. Here's what we'll do. We're going to copy this into a new folder, exercise 3. Okay. We'll paste everything here. And now we'll just revert back all of the stuff in exercise 2 to how it was. And that's the stuff I have open right now. So we didn't change art.h. We didn't change art.cpp. We did make these two new files, which we don't want anymore, so we'll delete them. And then here I'll just revert this back to how it was. Okay, not too bad. Now over in exercise 3, where we actually have our code. Exercise 3. Okay, here we go. We'll compile all of our CPP files. I'm just going to shorthand it like this. Oh, it's unhappy about title, and why is that? Okay, so this makes sense. And we can actually fix this in a nice, cleaner way. When we are using our look function, it's trying to access the title, and the title is private, which means if you're not part of the art class, you can't access the title. That sucks, right? But there is a way to make it so that it is not private but not public either. And that is, we're going to go to our art class, and we're going to declare, art.h, and we're going to say that all of these private variables are actually protected. A protected variable is mostly private, with one exception, which is the subclasses of art are allowed to access this. So, since it's protected, if I try to access this stuff in the main function, not going to work. It's no good. It's outside of the art class. It's not even completely connected. If I try to access this stuff inside the visual art class, then it will be okay because it is protected, meaning that it's not available to just anybody. But if you're a subclass of art, then it is all right. Okay. Continuing again. All right, that seemed to work okay. So we will g++-o our, what are we doing? Visual art? Of art, sure. From all of our .o files. All right, seems to have worked. Art. The screen, oh, I'm missing a space here to make it look nice. So let's fix that. In visual art.cpp, I forgot a space after the title. Okay, let's try that again. Compile and build and go. The screen is 4 square feet and it looks great. Sounds good to me. All right, and there we have it. We have done, well, the first part, we were supposed to do a performance art as well, so I suppose we should do that too. For performance art, I think what we'll start with is duplicating these and just changing the things to make it performance art. So this is going to be performanceart.h. So this will be performance art. It will have a duration in minutes. It's also going to have the same things that can build it. This is performance art, and we'll say applaud. Sure. And then in our performance art.cpp, we're going to include performance art.h. This is performance art. And we have a duration instead of a size. We're still going to use the super constructor the same way that we did before, the superclass constructor. Instead of look, we have applaud. And we'll say something like title was a great duration minute show by artist. Sure. Now, in my main function, I need to also include performance art. Yeah, okay. I'm going to copy most of this, except now I need performance art. And this will be PA is performance art. So this is performance instead of visual. Let's do Levitating by Dua Lipa from 2020. And the duration is, how long is this song? 3:50, 3 minutes 50. We're just gonna round it to 3, round it down to 3. Sure. PA.applaud. It was applaud, right? Yeah. Okay. All right. Let's see if this works. So same as before. Compile everything. What did I mess up? Okay. Here we go. So this is a thing I thought would happen sooner, but it has only now happened. Redefinition of class art. Why is that? Well, in our visual art.h, which somehow is one of the few I don't have open, I try to include the art header. In my performance art.h, I'm also including the art header, which means I'm attempting to declare art several times. Not so good. The most reliable way to fix this, and there are other ways to fix it, but I want to make sure that no matter what version of C++ you're using, it will work. If not defined art, we will define art and tell the computer, hey, we have access to the art header. This is a header guard, and we will end if down here. If we have not seen this header file before, declare everything in it. But if we have seen this header file before, don't declare things a second time. That leads to issues. Instead, just skip all that. And that solves my problem. Link all the objects together, and let's vart. Scream is 4 square feet, and it looks great. Levitating was a great 3-minute show at Dua Lipa. Sounds good to me. All right, there we go. And then we can continue on. Okay. 4, derive more specialized classes like painting and sculpture from visual art, adding attributes and methods unique to each, such as type of paint or material used. Do the same for song and dance from performance art, using attributes methods like album. Sure. So we're building this even deeper, going to another level, a subclass of a subclass. We're going to copy everything here this time and not forget to. Make a new exercise 4. Drop everything in. And now we need to make some subclasses. So what did we say to start with? Is painting and sculpture. Sure. So let's do a new file, painting.h. Okay, and now something that I want to do is I have this function display art. This isn't really what I mean. What I mean is display info. And I'll fix that in my art file here too, display info. And the reason for that is what I'm actually going to do as part of these classes I'm making now is I'm going to actually give them a display info too. And the display info function I'll make for them is going to include much more detail. And we'll see how this manifests when we try to run our main function. But the display info that I'm going to use for painting is going to include what does visual art have again? The size will have type of paint and all of the stuff that's already built into what we have before. So let's make our painting. I'll copy this so I don't have to keep going back and forth to the slides. Okay. Sure, sounds good. Now, I need to make visual art. Painting is a kind of visual art, so I need to include visual art.h. So I now know what visual art is, so I can say class painting, painting, inherits from the public class visual art privately has a string variable called type of paint. And publicly, it's going to have a constructor called painting, and it's going to take a string, int, string. I've memorized what we need to build these kinds of art things because we're going to need to have a art type, title, artist, year, size, and now type of paint. And I'm trying to keep it in a consistent order so that I don't have to, so it's not getting mixed up. You technically could rearrange these, but that becomes more confusing and it doesn't match the order that we've been following for everything else. So here's my constructor, and then the other thing I want to have is actually void display info. And this display info is going to override the art display info and show me stuff specific to this painting. Okay, so this is my painting, and then I need a painting CPP file. Here I include painting.h. I don't need to redeclare these things. I already know what they are. I do need to specify these are part of the painting class. And now I need to define them. Once again, we'll just take advantage of the fact that our superclass has a constructor already, so I can use visual arts constructor, pass it the first 5 things, which were art type, title, artist, year, size, and this is the paint. So art type, title, artist, year, size. And then the type of paint is P. To display info, we're going to say everything. So we're going to say title by artist. And here again, I know I made a mistake that I need to fix right away, which is that this is private again, which means that my painting can't access the size. So I'll need to fix this to make this protected. And in fact, I should do that for my performance art as well, to make the duration here protected too. Just a thing that I foresaw in the future will lead me to a problem. Okay. Now, I kind of want some of this stuff, but not really. I think I do want this, title by artist year. So, title by artist year. Is a painting, is a size square foot painting done in type of paint. A very long line of code. You can see 132 characters at least. You should generally not keep your lines of code any longer than 70 if you can help it. So I'm going to space this down a bit to make it look a little more readable. Okay, and there's my display info. Oops, let's just space that out nicer. Okay. Now, I'm going to do something very similar for sculpture, except sculpture is not going to have type of paint. It's going to have, what was it, material used? Yeah, material used. But before I do that, I should make sure that all of this code works okay. Because if it doesn't, I have a problem. So my main function here, we'll get rid of this. Well, actually, what we'll do is we'll leave the performance art part because I think that's fine. But our visual art, instead, we're going to get painting. And then this is going to be painting. P is painting. All these things. What was the scream? The scream paint type. Oil. Sure. Oil. And we'll do display info. And let's see if this works. In exercise 4, compile all of the code. I missed a arrows inside display info for painting, so let's go fix that. Here it is, arrows. Okay, seems happy. Build all my files. The Scream by Edvard Munch, 1893, is a 4 square foot painting done in oil. There we go. Okay. So everything seems okay for now, which means I'm going to duplicate my painting header and we're going to make it for sculpture. So we should be able to do things quicker now that we've done it once. So sculpture.h. Our sculpture.h is going to be a sculpture. Is also a kind of visual art. It is going to have a material used. It will also have a method called display info. And this is where the polymorphism part of this comes in, is that I actually want all of these types of art to have the same method display info that will work regardless. So here is my, my header file. And then my CPP file for sculpture will look just like the painting. So duplicate this. This is going to be sculpture.cpp. And we need to include sculpture.h. Sculpture, sculpture, sculpture. This thing is a square foot sculpture made of material used. And this isn't type of paint, it's material used, and we'll make the letter M to match. So that was pretty quick because it doesn't really look that different, which is nice. So that means I can make these new classes very, very quickly without having to retype things. Okay, so if that worked, then I can add a sculpture. Sculpture S equals sculpture, and we'll display it. Now, I know nothing about sculpting. Famous sculptures. Sure, David. Venus de Milo, there we go. 130 is the year. So let's see, visual, Venus de Milo, 130, technically BCE, so I guess negative 130. I don't know, 5 feet tall. Is it marble? Venus de Milo material, marble, yeah, I thought so. And who is the sculptor? This person, I don't know who this is, but that's okay. I'm not I'm not an art historian, I'm afraid. Made of marble. Okay, let's see if that works. Compile everything. So same issue here is now my sculpture and my painting are trying to both use the visual art header, so that's going to need to have its own header guard. And I'll steal the header guard from my art.h. Yoink. So now visual art will also have a header guard. Oops, that's the wrong one. It should be the visual art header. We'll have a header guard, but I'll define this as vart and diff. Fixes my problem. Compile and go. There we go. And now we can see they're both using their own display info, which is slightly different from one another. Okay, so that was halfway. Now we still have to do the performance art stuff. But I just want to peek at something really quick. Do I have to? Okay. Yeah, so one thing that I've noticed now is that this is getting really overwhelming. Like, look how many files are in here, right? So here's what I'm going to do is, first of all, I kind of want to clear all of the the object files to like actually focus on what is really necessary here. So I'm going to rm-f star.o, and this means delete all the object files. Also delete vart, because that's my executable. I don't need that right now. And then I need to click here to refresh it. Okay, so here is the actual stuff. Oh, I guess art ex doesn't need to be here either, but that's okay. Now, right now, everything is all in one directory, which is really poor organization. If I'm looking for certain types of things, it's all kind of just dumped in one spot. There's a lot of files. So I should be separating stuff into folders. And I can do that, and it shouldn't be too hard. And what we'll do is we'll make one folder, which will be visual art. And I'll put all the visual art stuff there. And then the performance art stuff will go into a different folder, which is performance art. So painting, sculpture, visual art are all visual art. Why did this not go in? Go. Unhandled error. What? Okay, it just didn't update. And then these will go in performance art. Now, there are going to be some errors now if I try to do this, right? Because now my source files are in all different directories, which is a bit of a problem. So I need to figure out how can I make it so that I'm still able to build everything from here. And here's what I'm going to do. So let's see here. G++ -C. Okay, so the first thing I need to do is note the fact that in my performance art thing here, I can't find art.h anymore. It's not in this directory. I need to actually go and go to the previous directory to access it. Because right now, if I go into performance art and I try to compile performance art.cpp, it says I can't find the art file. Where is this? And it's not here, it's one directory up. So now I can compile it, okay. And then similarly for visual art, I need to go up a directory. However, you'll note that all of the other visual art things all are in the same folder, so I don't actually have to really do much there, which is pretty nice. Now, my main function here needs to go and get these different art files. So I need to go into visual art /painting, visual art /sculpture, and performance art /performance art. Okay. Now, if I compile art.cpp, what? Oh, I'm in the wrong directory. Everything is fine. If I try to compile main.cpp, everything is okay. But I'm going to need to link everything together. And so this is where there might be a shortcut that I haven't thought of, but it might be the case that I actually just have to specify all the directories where these object files are. So let me see what happens if I do this. G++ -C, and we're going to experiment a little bit. Visual art /star.cpp, performance art /star.cpp, and everything.cpp here. Nice. So this is kind of cool. What I just did was I used G++ to build an object file from all the CPP files in all of my directories here. Visual art, performance art, and the current directory. And all those object files actually get dumped in here. Now that I have them all, I can use the simple command G++ O art executable, I suppose, all my object files. And there we go. Everything still works, but now I have my stuff all in separate directories. And of course, I can clean this all up by doing rm-f for all the O files. But this is nice now because it means I can start actually doing things in the folders rather than dumping everything inside of this one spot. Now, we needed to do our performance art as well. So I'm going to cheat a little bit. I'm going to bring the painting over because a lot of what the, so what did it say I had to do for the, for this exercise? Song and dance, okay. So performance art, yes, over here. I'm going to paste in painting, but it's not actually going to be painting. I want this to be song, and I want this to be song as well. And now here, I'm including performance art. This is the class song, which inherits from performance art. And song is going to be from a album. This will be song. It'll also have display info. So that's nice. It's done. And now here, I'm going to include song.h. Here's my song. It is a song. The last thing is going to be the album. So the album will be AL. And it uses the performance art constructor. The song display info function is going to say song title by artist year is a, and so remember here we have the duration, not the size. Duration, minute long song from the album. Okay, so that's all well and good. Close a bunch of these tabs. Let's go back to main. And now I don't need to include performance art. What I'm going to do is include performance art slash song. Because this is a song. SO is song. Performance levitating 3, and this is from Future Nostalgia. SO dot display info. Now let's see how we do. So again, compile all over my code, link all of my objects together, and execute the thing. Levitating by Dua Lipa 2020 is a 3-minute long song from the album Future Nostalgia. Hey, not so bad. Okay, last part is the dance. Okay, I'm very bad with dances. What is a famous dance performance? Okay, these are questionable. Most iconic dance ever. Well, no, this is a dance move. I don't want a dance move. I want a dance show. These all seem very recent. The most famous dance show of all time. I don't want to waste too much time on this, but I would like to have something. These are TV shows. Google sometimes is really, really useless about showing you things. Okay, we're just going to go with some kind of ballet. Famous ballet. Sure, the Nutcracker. Why not? Nutcracker. Composer. Tchaikovsky. Okay, sure. Let's see if I can assemble the things to to put this dance in here. Okay, first of all, I need a dance, so I'm going to duplicate these. I'm going to call these dance instead of song. Dance, dance, revolution. Dance. This is a dance. It's not going to have an album. It will have a style, I guess? Sure, why not? Okay, that was easy. Dance.cpp will have a style, we'll say is S. This will be S. This is a dance, not a song. Dance, 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 dance. This thing from this is a long dance in style. Sure, that'll do. Now my main function, and here I think again my performance art header is going to need that if not defined part. Part. We'll define part and if. And now I will include dance, and we'll make a dance. It's going to look a lot like this, except it is a dance D. Is a dance, is a performing art, is the Nutcracker by, I'm going to spell this wrong, so I'm going to copy it. This guy. Paste. Did it really not paste? There we go. What year is this? 1892? Sure. 1892. Nutcracker length is 1 hour 50 minutes, so it's 110 minutes. It is the ballet. And we'll do d.display info. Okay. Once again, build everything. Whoop, we got lots of problems here. I must have messed up something with the song. Forbids declaration of song with no type. Interesting. In my dance.h. Oh, my dance.h has a mistake. It should be dance, not song. There we go. Clear that up. Try again. Okay. Build it all. Run it. And hey, we got all 4 of them going. Okay. And the nice thing now is that if I want to tinker around, let's say I want to tinker around with maybe just one of these files, right? I want to add one more method to dance. I don't have to rebuild everything. The only thing I have to do is recompile the dance CPP, build the object file for it, and then I can link everything together. This is a lot quicker than needing to recompile every single CPP, and it's all nicely organized. The only thing that's not organized is there's lots of object files here, which I probably should clear up when I'm done. But that's good for this exercise. Let's move on to the next one. Okay. Exercise 5. Make a museum class that contains a vector of pointers to objects of type art. Implement a method to add art objects to the museum's collection. Okay, sure. So, first of all, I need to copy everything. Copy. New folder. Exercise 5. Did not want to make a new file. I want to paste everything. Can't copy directories is quite annoying. This is an unfortunate drawback of Jupyter, so I actually have to manually copy these as well. Copy. Or actually, can I copy a directory in terminal? It's possible, but I'll maybe figure that out another time. Jupyter sometimes does frustrate me though. So I need a visual art folder and I need a performance art folder. Dump all my visual art in here and dump all my performance art in the other one. Copy. Okay, good enough. Now, let's make a museum. So, first of all, let's rm-f anything that says .o, just to clear this space up a little bit. It's very messy. Okay, much simpler. Now, I want a museum. So, museum.h. It's going to have my museum. I'm going to need to include a vector, because I want a vector of pointers. I need to include art.h, which fortunately for me should include all the IOStream stuff, so I shouldn't need to do anything else. And now I have a class called museum. It is going to have a private vector of art pointers called collection, I suppose. And then publicly, we'll have a museum constructor What does it say we have to have? A method to add art objects to museum's collection. So void add art, and this will take a art object, and probably void. This will be show art. Why not? Duplicate. Here is my museum.cpp. Does not need the declarations, because those are done. It does need to include museum.h. Museum. We won't have it do anything with this constructor. I think that's okay. We need to add art and show art. Now, adding art is pretty simple. Our collection, I believe it is called a collection. Dot push back. And now here it's a pointer, so we want the address of the art. Another option is that we could also have it accept the pointer itself instead of accepting the art object, in which case we would just need to do it something like this instead. But I think what we'll do instead is we'll actually just have it take the address. We'll take an art object as the parameter, and we will pass the reference to our collection. Well, actually, I don't know if that works. I think I have to pass it by reference if I want to do that. This should work. We'll find out, of course. And now to show art is pretty simple. For I is 0, I is less than the collection size, I plus plus. Collection I dot display info. And this is nice because remember, all of our art has info that we can display. So if we've done this all correctly, what we can do now is go to our main. We can include museum. We'll remove all these display infos. Oops. And instead we'll make our museum. Add art. We'll add the painting. We'll add the sculpture, the song, and the dance, and then we'll do m dot, what was the name of it? Show art. And now let's see what happens. Once again, we build everything. Oh, made a mistake. Oh yes, we have to correct our header because our header is supposed to have a reference to an art. Try that again. In show art, there is a problem. I meant to use the arrow because the collection contains the pointers, not the art itself. So I need to change this dot into an arrow in my implementation. Arrow. Okay. Link everything together, please. And go. And now here's something to note. And this is not something we'll be able to solve this week, but we will solve in the next video. All of these no longer say the same messages they had before. They all use the display info from the original art class because our museum only knows about art, just general art. So when it tries to display info, it displays info using what art display info has. It will not use the unique display info that belongs to each of the individual types of art that are there. Sometimes that might be what you want. Maybe it's the case that you actually want to use this display info. Maybe you want something more precise. Next week we will show you how you can use the same messages we were doing before where we individually did all these display infos. But for the moment, we're just going to be able to display generic art information as noted here. Okay. And yeah, okay, so that's good for now. Let's go on to the next one. All right. Implement an appreciate art method in the museum class. It should loop through each art in the collection. Depending on its art type, print out a message that appreciates that specific form of art. Okay, it's not too shabby. We kind of are doing this already with our display, but that's all right. So once again, I need to, I guess there's no way to duplicate the folder, unfortunately, huh? I wonder if there is a faster way. There's got to be a better way. Is there a better way? Okay, well, we'll try it, and if it works, it works, and if it doesn't, it doesn't. So copy, and now what's the flag that I want? I think it's -R, exercise 5 to exercise 6. Did that work? Ah, okay, there we go. So this is where it really does pay to know about the different kinds of terminal commands, because at one line I can copy all of my recursively copy, as in go through every folder and grab everything from exercise 5 into exercise 6, rather than me having to like click and drag, copy this, click and drag, copy this. You just do it in one line. But you have to know how to do these lines in order, or you can do what I did, which is look it up. Okay, so what are we doing? We are adding some content to our museum. So in our museum, we are going to add a appreciate art. So we have show art, we'll implement appreciate art. Loop through each art in the collection, depending on its art type, print out a message that appreciates that specific form of art. Okay, so this actually would be pretty simple because we kind of did some of this work when we did the show art, but that's okay. So we got appreciate art. And kind of the same thing, make another loop. For each thing in the collection. If collection I art type is visual, we'll say, wow, title is super interesting to look at. Sure, why not? Else if it is performance art, was such a great thing to watch. Sure. I'll say experience. There we go. Amazing. Why not? And this is appreciate art. So this was pretty quick to implement, which is nice. I only had to go into the header, add this one function that we're going to add, go into the CPP file, put in the new code for this, and then the main, we have show art, and then we'll have m.appreciate art, and that's it. Now, the cool thing is, when I go to build this, I can build this a little faster. Let's go into exercise 6. So right now I have all these object files from everything I built. I do not need to compile everything. I only need to build the object files for the things in this directory because I have the object files for everything else already. So I'll build everything that's here, and then I will link everything together. Oh, okay, I made a mistake. What did I mess up? Show art. Did not print anything out? Appreciate art. Oh, maybe the art types are not correct? Visual and performance, right? Visual, performance. Something weird has happened here, and I guess I want to find out. First, let's see if this function ran. Oh, I modified the wrong file. That's what it is. Okay, so we can fix that easy enough. So these are my museum files. So I'm just going to go here, copy these to my root directory. So those are the ones I want to keep. And then in public videos in here, these are the old ones, which have the old code. I'm going to copy these over here, paste. I don't want them to be copies. No, I want to have them be the real thing. Paste. Oh, I hate that Jupyter does this. It'll only copy it temporarily. As soon as you paste it, it forgets things. Very annoying. Okay, paste. There we go. Exercise 5 is back to being okay. Then exercise 6, copy, delete these, yes, paste. Okay, let's try this again. Okay, I made a mistake. What did I mess up? Art type is protected in this context. Right, because museums are not subclasses of art. They can't access the art type. So I'm going to declare that museums are a friend of art so that they can access those properties. And I'll do that over here. Friend class museum. And let's see, it says title here, but it shouldn't be title. I need to actually grab the thing. Museum.cpp. Yes, it's collection title and collection title. So now that my museum is a friend of art, it can access those protected variables that I want it to be able to collect. Okay. I suppose the other option is I could also use the get art type function, is also fine. But I think a museum should be friends of art. If it's not, that's bad use of a museum. Okay, try again. Okay, compiled okay. Can we link? We can link. Can we run? We can run, but it's still not doing what I want. Let's find out why. Oh, I think the main function we also didn't do correctly. So this is what I want for my main. And let's fix the main here. Okay, easy enough. Compile, link, go. There we go. Okay, now it's running. So I can get rid of that ran line that I put just because I didn't know why it wasn't working. Compile, link, go. Wow, interesting to look at, great to experience. Hooray, we did it. Just needed a few little fixes, but these are the kinds of things that happen quite often, and it's worth knowing how to do these kinds of quick fixes. Okay, we're almost there, only 2 left to go. Let's see how that pans out. Okay, derive a gallery subclass from the museum class that specifically contains paintings instead of any art object. All right, so once again, we're gonna take advantage of us knowing how command line can be used to copy recursively everything from exercise 6 into exercise 7. I'm also going to be more smart this time and close all my tabs so I don't edit the wrong code. We'll go over here. Okay. I need a new file, which is going to be gallery.h. And let's copy our instructions. Well, our instructions are pretty simple. Make a gallery. Okay, so we need to include museum.h. Why did I go down? There we go. And we'll have a class called gallery. It inherits from the museum class. And privately, it is also going to have a vector, but this time I want a vector of paintings, which means I also need to include a painting. And that is inside the visual art folder in the paintings header. Now, I want a vector of painting pointers, which is also called collection. Now, there's some arguments of this is a good or bad idea or not. What I'm actually doing here is I'm making a second variable inside the class that also is called collection. Technically, the other collection, the vector of art pointers, is here too, but I'm never going to use it because I want my gallery to only be able to use the vector of paintings that I'm going to be building. The main purpose for this is I want to make sure when I display info, it displays all the painting info, not just generic art info. Now, for my public methods, let's see what the museum gives me. Museum has add art, but I want to be able to add paintings. Do I want to be able to show art? I do, but I think I want my, what is it? Do I want my show art to do the same thing? It says, for each thing in here, display info using the art display info. One thing we can do, and we'll see what happens, is actually try not implementing these and see what occurs when I do it. So I'll just leave the gallery constructor here and nothing else. And we'll see what actually happens if I try to make this work. The CPP file for this is going to be very short. So gallery.cpp. We'll include gallery.h. Nothing really there. Not a lot of declarations. And my gallery constructor will not do anything. This is the saddest CPP code you've ever seen. My main function will include a gallery. I suppose I need a second painting. So we'll do painting P2 is Mona Lisa, Leonardo da Vinci. When was the Mona Lisa painted? 1503 potentially. Sure. Da Vinci, not Da Vinci. Oop. No, Da Vinci, 1503. Also in oil. How big is it? I'm pretty sure it's like really small too. Size. This is what, like 2 feet square? Something like that. 2. Again, that could be totally wrong on that. But anyway, the reason I want to do that is so I want to add 2 paintings to my gallery. So now I can go gallery G, G.add art, P, P2, and P.show art. And I'll get rid of all the museum stuff so I'm not flooding the output. Okay, let us go into exercise 7 and compile all this stuff. Remember, I haven't modified the visual or performance art at all, so I don't need to compile them again. Okay, I got lots of problems here. Redefinition of museum. It looks like I am redefining both paintings and museums a few times, so I need some header guards for those files. So here I need if not defined muse, define it, and if, and then same for painting in visual art dot h, if not defined painting, define painting, and if. Painting has no member called show art. P.show art. Oh, it shouldn't be P.show art. It should be G.show art. That's why. Link us together and go. Okay, so what we can see here is happening is it is still using the old art. It is treating these like art objects, which is not really ideal. So I need to handle that. I need to tell my gallery that when I am going to show art, so I need to show art. And then how's my museum implemented? It's like this. And let's see if that does anything. It might not, but maybe it will. Well, let's see, what's our problem here? Okay, so it's unhappy because I am declaring let's see, undefined reference to gallery.showArt. But I built that, right? I think it might be unhappy that I am declaring it twice. Now what happens if I don't declare it twice and I just put it, oh, here's the problem. This should be gallery show art. There we go. Okay, and now I have to declare it, so I do need to put it there. Okay, I just forgot to change this from museum to gallery. It should be gallery. And this is supposed to declare it again because it is part of the gallery class. Compile, great. Go and go. Okay, well that was very sad because nothing happened. Not great. Now, why did nothing happen? My guess is that when I am adding art, it is adding art to the collection of generic art objects. That's not really what I want. What I want is a gallery add art option that takes a painting and puts it into my painting collection. So I'm going to need to have add art here. And this is going to take a painting reference instead. Copy this. Yeah. And now this is going to be gallery.addArt, and it's going to take a painting and push that into my collection. So now, when I compile this, link it, run it, there we go. We have the actual painting version of the output. And so in order for this to work, I needed to redeclare these different methods. They have the same name. And so if you're using a museum or a gallery, you can still use show art and add art. But they work differently because the gallery only accepts paintings. And so now I am kind of curious if I need to do gallery.showArt. What happens if I don't? If I don't put this in and I delete this, does this work? Okay, as I thought, nothing is printed. Why? Because if I don't declare a specific gallery usage of showing art here, which I need to have, then when I try to show art from the gallery, it says, oh, okay, well, galleries can't show art, but museums can, so I'll use the museum method. And what does the museum method do? Well, it says go through all your art objects, your general art objects, and display them. I don't have any. All I have are paintings. So my gallery won't show any art unless I have not only made my add art, adding paintings, but my show art redefined specifically for a gallery. Okay, but that is at least this exercise done. We can move on to the last one. All right, final exercise. Allow filtering of the art pieces in the museum's collection based on specific criteria. For example, only display visual art pieces, only display dance performances of a certain style, or so on. Okay, so once again, go back, copy recursively exercise 7 to exercise 8. Close all my tabs, and go here. Okay, so my museum needs to allow filtering. So what we'll do is when we do our, let's say we do our should we do show art? I suppose show art is fine. Right now, show art just displays the info for any piece of art. But what we'll do, I think, is we will have some filters here. Or maybe just a filter. Display visual art. I'm trying to think of what's a good way to do this. So probably the nicest way to do it is to have a few other options for showing art. Maybe we'll overload show art just for the what's them called? For the different types, like visual or performance. And I think maybe I can leave it as a bit of an exercise to see what other kinds of filtering you can do with this. But let's say that I want to have two versions of show art. One that just shows all your art, and one that only shows art for a specific art type. So copy this, and this is going to take string at for art type. And now here, if collection I arrow art type equals at, then I will display the info, and otherwise I will not. Very simple change. And maybe I guess I can do another one. What did it say? Dance performance of a certain style. Yeah, there's a lot of different ways you can do this. It kind of depends, I think, on what kinds of things you want to show. And I think for this scenario, we're just going to stick with showing art of maybe with of just the art type. So let's remove our gallery for a moment and bring back our museum. And now we'll show just the visual art. Say, for example, we won't appreciate it right now. Maybe that's actually something we can do, is we can have the appreciate be something where we only do what was the thing again, of a certain style. Just thinking of the nice thing about this is there's actually lots of things we could do depending on exactly what we're looking for. I think I'm going to leave this simple because this video is already pretty long, and we're just going to have the two different versions of show art where I can decide if I want to show only visual or performance. And so in my main function, I say I only want to show the visual art. So once again, I will compile just the stuff in this directory. Whoops, wrong directory. Exercise 8. This directory. Link it all together. And go. And here it just does my visual art pieces, and now if I want to just show the performance art pieces, I can do that as well. Compile, link, build. And you can see this is pretty quick in terms of compiling. If I were to build everything again, which I can, I mean, I just have to go back to the lines of code like this. Like, that's a bit of a delay, right? Like, I have to wait a little bit for this to build everything, which is kind of annoying. But now when I only change a few files, I can just compile those, make the objects, and then the linking part is very, very fast. So, okay, but I think I want to wrap things up there. With regards to these filters, you can do all kinds of stuff with this. Maybe you want to put some text input in there and ask the user, hey, which do you want to display, that kind of thing. But this is, I think, a good finishing point, at least from my side, that gives you a chance to play around a little bit with this. Modify these museums and galleries. Maybe instead of just making a gallery, make also maybe a theater. A theater can inherit from museum, and it can perhaps only have a collection of performances, and then you can show the performances, and so on and so forth. But it's mostly, I think these exercises are important just to demonstrate how these classes connect with one another, how a gallery is a kind of museum, a sculpture is a kind of visual art, which is a kind of art, and how they all inherit different properties from one another. And the one thing we didn't really get to do was figure out how to make it so our museum would display each unique form of information. So right now, if I display info from museum, it just displays the generic art info. In our next collection of exercises, we can show how you can have a collection of all of the same kind of overall thing, like all art, but use the specific methods that belong to that object, such as a sculpture's display info instead of just a generic piece of art's info. But that's more for later. We've already gone through quite a bit of stuff together, so thanks for watching if you made it this far, and I'll see you in the next video. Goodbye.